If you are installing your jump-out code, there are two ways to do it. Let's look at the code of the Tricore Aurix-based ECU operating system. Both ways are used here for slightly different purpose. But first about what these ways are. The first is implemented by performing a direct conditional or unconditional jump using the J instruction, and the rest of the group of J-based conditional instructions, for example, J and Z, jump non-zero. The second is to use the call function for this. As can be seen from the factory code, the first way, for example, based on indirect or direct jumps using the J instruction and its conditional equivalents, is the way used for non-distance jump, allowing the instruction of conditions in the code and correcting the movement of the code execution. I just show this now with my mouse. You can see the arrow which points from where jump occurs and where it hits. From the higher level language in which the controller software is written, instructions such as if, case, of, while, for are converted into the assembler code in this way. That is, all where a condition is checked or comparison of variables happens. The J instruction is the equivalent of the higher level go to or jump to instruction. The other method is used when the jump to another function is implemented. In the higher level languages, it is calling a subfunction or method in a class, passing its parameters, and retrieving the results of that function of method. There is a fundamental difference between direction on the microprocessor registers. Using the J function passes all the variables that are in the A address registers and the data registers further into your code. So you are actually extending the factory code by some new chunk. It is using the call function that requires an understanding of what the upper and lower contexts are. Both data and address registers are divided into upper and lower context registers. If the registers belong to the upper context, then when the function call is executed inside the target function, they will not be protected at termination and will be overwritten with old values after the return instruction written from some subroutine. The registers of the lower context, on the other hand, will be passed to the target function to which the call instruction points. They will not be protected. When the ret is executed, their previous values, which were then before the call instruction was executed, will not be restored. This is why we use lower context registers to pass variables from functions we have written. Of course, we can also use them to pass variables or parameters of the function directly to it, and we do not need to use the RAM for this. To avoid the common problems encountered by novice Tricore assembler programmers, please read the processor documentation and search for the phrase upper or lower context and read with understanding.